Hi everyone, in this video I'm gonna introduce two algorithms for frequency estimation, Pisarenko and Root music method. Previously in this channel I talked about the music algorithm and I would like to present a summary of it. We have a structured correlation matrix in many applications. R equals to A P A Hermitian plus sigma 2 I m. N is the number of sources and m is the, for example, the number of elements or the number of sensors in the field of array processing. We eigen-decompose correlation matrix and we find and form noise subspace by putting eigenvectors corresponding to m minus n smallest eigenvalues of R in G. Then we form a pseudo spectrum and, for example, P omega equals to A Hermitian omega G Hermitian A omega. And frequency is the location of the peak of the pseudo spectrum. And one problem in music algorithm, it's based on computational complexity. We have to do grid search to find the location of peaks of this spectrum. That's why they continue to present other algorithms which are simple in terms of computational complexity. Of course, we sacrifice statistical accuracy because we are looking for algorithms to be easily implemented. In Pisarenko method, m minus n equals to 1. What does it mean? It means we only have one vector in noise subspace. So we only have one vector. And we can write, based on the idea in music algorithm, A Hermitian omega G equals to 0. A omega is 1 E minus J omega in E minus J omega minus 1 transpose. We put Z equals to E J omega and define A Z equals to 1 Z minus 1, Z minus 2, Z minus M minus 1 transpose. So I can write this A Hermitian G as A Z minus 1 transpose G equals to 0. This gives me a polynomial. I can write it k equals to 0, m minus 1 is n, g k, for example, z minus k equals to 0. And then I can find the roots of this polynomial. This polynomial have n roots, for example, zk, and by finding the angular of roots of this polynomial, we can find the frequencies. Actually, zk equals to e j omega k equals to phase of zk. This is really simple in comparison with the pseudo spectrum. We call this Pisa This is Pisarenko method. Let's continue with the root music algorithm. In music algorithm, we had A Hermitian omega, G Hermitian, A omega must be equals to 0. And again, if I put Z equals to E J omega, I can write this as A transpose Z minus 1 G Hermitian A Z equals to 0. I can factorize the roots of this polynomial comes in pairs and in reciprocal. I mean, if Z self is the root of this polynomial, then Z self minus 1 is also the root of this polynomial. Reciprocal pairs, we have m minus 1 reciprocal roots. We can factorize this to alpha Z alpha conjugate 1 over Z conjugate equals to 0. And alpha Z is a polynomial. I can write it as k equals to 0, m minus 1 alpha k z minus k equals to 0, and our frequency is the roots of this polynomial. But this polynomial is the order of m minus 1, and here m minus 1 greater than n in this scenario. So what should I do? I have to select n roots from the m minus roots. I select the roots that the absolute value of that roots are near to 1. I mean, we select the roots that are near to the unit circle.